Okay, just something I didn't do in any of the previous Surds videos is sort of like an expansion, something like say 2 root 3 plus root 5. Surds behave exactly like every other number, and if you've got something like this, you can just expand the bracket like so. Okay, so if you expand this, 2 times root 3, 2 times root 3 is just 2 root 3. And then what's 2 times root 5 is 2 root 5. Okay, so you just expand it as per normal. If you've got some other situation where you've got, like say, root 3 plus root 7 times root 2 minus root 5, something like that. Again, it behaves exactly like algebra. You multiply, you like FOIL, you expand the brackets like such. Okay, so let's have a look at that. If we expand it, let's do it. What's root 3 times root 2? Well, that's equal to root 6. Root 3 times root 2 is root 6. What's root 3 times negative root 5? Well, that's negative root 15. Okay, root 3 times root 5, 3 times 5 is 15, but we've got a negative there. So that's the second lot. What's positive root 7 times root 2? That's equal to positive root 14, 7 times 2. And what's root 7 times root 5? Well, that'll be 35, but it's negative root 5, so it'll be negative root 35. Just before we move on and say that's the answer, let's just check. Is there any factors of 6 that are perfect squares? No. Is there any factors of 15? No. No perfect squares going to that. No perfect squares going to 14, it's only got 2 and 7. And 35, no, there's no perfect, so that is our final answer. And that's how you expand brackets. Right, let's get on to, I'll do rationalising denominator in 2 videos because that gets a bit messy. Denominator. Okay, rationalising denominators. Fantastic. What we've got is, shall I start with the problem? Let's start with the problem. Mathematicians hate this situation here where you've got a surd on the bottom line of a fraction. Remember, denominator means bottom line of a fraction. We don't like this, and so we have this trick to be able to get rid of this root 7 on the bottom line. Now what that trick is this, I don't know if you've noticed it yet, but let's have a look at this. Does anyone out there in YouTube land know what root 7 times root 7 is equal to? It might not be immediately obvious, but what's root 7 times root 7? Well, we can put it together inside the bracket. 7 times 7 is 49. And, oh, hang on, that's a perfect square. Root 49 is equal to 7. Can you see the link between these two? And that always happens for anything. You could also write root 7 times root 7 as root 7 squared. And you can see that that's going to be equal to 7 because the square just does the opposite of the square root sign. It's like saying what's 1 plus 2 minus 2. Those things just negate each other and you just end up with nothing. You just end up back to 1. So so this is what we get. And it's this property here that we use to rationalise the denominator. So let's have a look up here. If I want to get rid of this square root sign on this root 7, what I can do is multiply that bottom line by root 7. So by itself sort of thing. But that would be changing the value of this number here, and that wouldn't be good. And so what we do is we actually multiply both the top line and the bottom line by root 7. And that in fact does not change the value of this fraction at all, because we're just multiplying by 1. This whole thing here is just 1. Anything divided by itself is equal to 1. So we're not changing the value of it at all, which is a good little trick, don't you think? So let's do it. What's 2 times root 7? It's just 2 root 7. What's root 7 times root 7? It's just 7. And so that is your answer. What we've done is rationalised. In other words, we've taken something that's irrational, a surd, and we've made it into rational, this 7 over here. Okay, let's just do, it's not much more to it, to be honest. Minus 3 root 2 over root 3. Let's just have a look at that as another example. Okay, how do we get rid of this root 3? Well, we need to multiply by root 3. So let's multiply the bottom line by root 3. we're not allowed to do that, remember, so we need to multiply the top line by root 3 as well. Let's multiply this out. What's negative 3 root 2 times root 3? Well, we've got this negative 3 at the front. And then what's root 2 times root 3? Well, that's root 6. Okay, so that's the top line. And what's root 3 times root 3? That's just 3. Are we done? No, because we've got a bit of cancelling to do here. So what we've got is we've got this 3 that cancels out with that 3 on the bottom line. And so you end up with negative root 6. And that's our answer there. Okay, so that's how you rationalise the denominator. I'll come back with the last little piece of the puzzle for rationalising the denominator in a separate video.